Okay. Hi, this is Eileen, and today we're going to be doing a multi-step mole conversion. Alright, so the problem that we're doing right now is what is the volume of 6.5 grams of helium at STP? So the first thing you're going to want to do is you're going to want to locate your find and your given. So the values they're asking you to find in the problem and the values that they give to you in order to find. So our find in this case is going to be volume. And so it's really helpful to think ahead and think about what unit that's going to be in, because that's going to help you later just for organizing your thoughts. So it's going to be in liters, which we know, and the given is going to be 6.5, sorry about the noise, 6.5 grams of helium. Okay, so you're going to want to think about what conversion factors are you going to need, what are you converting, how many conversion factors you're going to need. So since this is multi-step, you are doing two different conversions, which means you're going to need two conversion factors. So you're converting from helium, you're converting grams to moles, and then from moles to volume to get your final unit of volume. So we're going to need, our first conversion is, if we think about the simpler one for volume, is Avogadro's law. So we know that 22.4 liters of helium is equal to 1 mole of helium. That's just a given. Nothing we need to do to calculate that. But for the second one, we're going to use molar mass. So molar mass is equal to atomic mass. So atomic mass you're going to find on the periodic table. Since helium is only one atom in this case, you don't need to do any multiplication or addition. You just need to find the atomic mass of helium on the periodic table. So our molar mass and atomic mass is going to be 4.002602 grams of helium, and that is going to be equal to 1 mole of helium. So that's how you, in any case, that's how you're going to find grams, not just helium. Alright, so now you're going to set up our table. So since it's multi-step, it's going to be 2 by 3. And it's really important to remember that these vertical lines signal multiplication, while this horizontal line signifies division. So that's going to help when we're doing the mathematical part of it. So first off, always remember that, at least in this chemistry, or for now, we're not going to put anything in this box. So we're going to start out in the top, always with the given. So in this case, our given is going to be here, 6.5 grams of helium. So 6.5 grams of helium. Okay, so now we're going to have to start thinking ahead and think about what we want to put in each box so that they cancel out. So if you look at the conversion factor, our first step is converting from grams to moles, which means you're going to use the second conversion factor, molar mass, in order to do that first part of the equation. So here you go. You want them to be, you want the same units to be diagonal from each other so that they cancel out. If they're across from each other or on top of each other, they're not going to cancel out properly. So which half of the equation do we have to use first? We're going to use this half because it has the same units, grams of helium. This one has moles of helium, so nothing would cancel out. So here we're going to put 4.002602 grams helium. So we're done with that one, or that part. And so now we have to use the other half of the equation. You have to use both halves of the equation because that's the conversion factor. It doesn't make sense to use just one half. So now we're going to use the other half, 1 mole of helium. So here we're just going to put 1 mole helium. Sorry about the squeaking. And then, so same idea, we want the same units to be diagonal from each other so that they can cancel out. So now we're using our second conversion factor in the second half of our equation. So we want moles of helium to be diagonal from each other so that they can cancel out and leave us with liters, the unit we want. So once again, we're going to use 1 mole of helium. And then that leaves us with this half of the equation, 22.4 liters of helium. So you're going to cancel out grams of helium. You're going to cancel out moles of helium. And that leaves you with liters of helium, which is perfect because liters are the values or the units that correspond with volume. Okay, so now you're with the mathematical part. Okay, so we know division or division and multiplication are signified by these lines. So you know also that by multiplying it by 1, you're still going to have the same value. So generally, we don't have to worry about the ones, because if you do 6.5 times 1, it's still going to be 6.5. So the equation you're left with here is you're going to have 6.5 grams, or not grams because those canceled out, you're just going to have 6.5 over 4.002602 times 22.4 liters of helium, because those are your units that are left over. So if you do this on the calculator, you can do it step by step, or just do it left to right essentially, and you're going to be left with the raw answer, we haven't done anything to it yet, of 36.3763372. But now we have to think back to significant figures and think about if that's a proper answer. It's not. So we have to go through each one. This one has 3 significant figures because they're all integers. This one has a lot of captive zeros. It has zeros, but they're all captive, which makes them significant, which means that we have 7 significant figures here, and we have 2 integers, so 2 significant figures here. So we're going to have to use the least. So 2 significant figures is what we're left with. And this won't round up because it's a 3, so that leaves us with 36 liters of helium as our final answer. So let's box that if we can. This one's kind of out. Maybe I'll go over it so that everyone can see better. 36 liters of helium. So now, the answer to the question of what is the volume of 6.5 grams helium at STP is 36 liters of helium. Okay, thank you.